The sky appears calm. There are no signs of danger. Yet high above, a massive unmanned aircraft moves almost unnoticed, far larger than typical drones, gliding slowly beyond the reach of conventional eyes and sensors. This is GJX, not just a stealth drone, but an aerial platform designed with a clear purpose: to fly farther, stay airborne longer, and remain difficult to detect. In this video, we are not comparing power or discussing threats. We are focusing on technology, on the concept of strategic range, and why it is this capability that has placed the GJX at the center of global attention. Section 1. What does strategic range really mean? In modern aerospace analysis, range is more than a number on a map. Strategic range refers to the ability of an aircraft to travel long distances from its base, remain airborne for extended periods, operate effectively in complex airspace, gather useful information without being detected. For a drone like the GJX, range is not just about how far it flies, but how far its influence extends. This combination turns an aircraft into something more than a vehicle. It becomes a persistent presence in the sky. Section 2. Why size matters. One of the first things analysts noticed about the GJX is its large size. This is not accidental. A wide wingspan allows greater lift efficiency, lower fuel consumption, better stability at high altitude. Long, slender wings are ideal for sustained flight. They allow the aircraft to remain airborne for many hours, sometimes more than a full day, without refueling. In other words, size enables endurance. And endurance is the foundation of strategic range. Section 3. Stealth as a range multiplier. Range alone is not enough. An aircraft that can fly far but is easily detected has limited usefulness. This is where stealth design becomes essential. The GJX appears to use smooth blended surfaces, minimal vertical structures, internal payload bays, radar reflective angles carefully reduced. The result is an aircraft that can operate closer to sensitive areas without triggering early warning systems. Stealth doesn't just protect the aircraft, it extends its effective range by allowing it to operate where other platforms cannot. Section 4. Engines built for efficiency. High-speed flight consumes fuel quickly. Strategic drones don't need speed, they need efficiency. The GJX is likely powered by an engine optimized for stable cruising speeds, long duration flight, reduced fuel burn. By prioritizing efficiency over acceleration, the drone can remain in the air far longer than tactical platforms. This design philosophy reflects a shift in modern aviation. Staying airborne matters more than getting there fast. Section 5. Altitude and the upper layers of airspace. Another key factor in strategic range is altitude. The GJX is believed to operate at very high altitudes, similar to Hale-class drones. Flying higher offers several advantages. Wider sensor coverage, improved fuel efficiency, reduced exposure to conventional defenses. From these altitudes, a single aircraft can observe vast areas of land or sea, expanding its operational reach without moving closer. Section 6. Sensors that extend range beyond distance. Range isn't only physical, it's informational. The GJX is expected to carry advanced sensors such as synthetic aperture radar, electro-optical and infrared systems, electronic signal collection equipment. These sensors allow the drone to see and collect data from great distances. In many cases, it doesn't need to cross into contested airspace at all. Its sensor range extends its strategic value far beyond its flight path. Section 7. Communication over long distances. A long-range drone is only useful if it can communicate reliably. The GJX likely relies on satellite communication, links, redundant data pathways, semi-autonomous mission systems. This allows the aircraft to operate far from its control stations, executing complex missions with minimal direct input. Autonomy and connectivity turn physical range into operational freedom. Section 8. Strategic range as a technological signal. Beyond practical use, strategic range sends a message, not of aggression, but of capability. It reflects advanced aerospace engineering, mature industrial capacity, integration of design, software, and systems. When a platform like the GJX appears, analysts pay attention not to a single feature, but to the system as a whole. Section 9. Why the world is watching. Global interest in the GJX isn't about one flight or one image. It's about the convergence of size, stealth, endurance, high altitude, performance, long-range sensing. Together, These elements represent a shift in how airspace can be monitored and understood. And that's why discussions around strategic drones continue to grow. Section 10. The future of long-range drones. The GJX is part of a broader global trend. In the future, strategic drones are likely to bridge the gap between satellites and crewed aircraft, provide persistent aerial awareness, support scientific, environmental, and security missions. Their value lies not in confrontation, but in information, endurance, and reach. Section 11. Range as a system, not a single feature. One of the most common misconceptions about long-range aircraft is the idea that range comes from a single breakthrough, bigger fuel tanks, a better engine, or lighter materials. In reality, strategic range is a system-level achievement. For the GJX, range emerges from the interaction of aerodynamic efficiency, engine optimization, structural design, sensor placement, data processing and communication. Remove or weaken one element, and the entire system loses effectiveness. This is why platforms like the GJX are not easily replicated. They represent years of iterative design, testing, and integration, where every decision supports the same objective: staying airborne longer, farther, and more effectively. Section 12. How strategic range changes mission planning. Traditional aircraft missions are constrained by distance, time, and crew fatigue. Strategic range drones change this equation entirely. With a platform like the GJX, missions can be planned days in advance. Coverage areas can overlap continuously. Aircraft can loiter rather than transit quickly. Instead of short, high-intensity sorties, strategic drones enable persistent observation. This persistence is often more valuable than speed. It allows analysts to observe patterns, changes, and long-term developments, something brief flyovers cannot provide. Section 13. The human factor, range without a pilot. Another key advantage of strategic range drones is the removal of onboard crew limitations. Human pilots face fatigue, oxygen constraints, physical endurance limits. The GJX does not. Without a pilot onboard, flight duration can be extended dramatically. Operating altitudes can be optimized. Risk calculations change entirely. This does not remove humans from the process, but it shifts their role from cockpit control to mission management and analysis, enabling longer and more complex operations. Section 14. Strategic range in a data-driven era. In today's aerospace environment, range is valuable not because of where an aircraft goes, but because of what it collects. The GJX operates as part of a broader information ecosystem. Sensors gather raw data. Onboard systems filter and process information. Communication links relay insights in near real time. In this context, strategic range becomes a data multiplier. The farther and longer an aircraft operates, the more complete the picture it can build. And in modern aerospace strategy, information continuity is often more decisive than momentary access. Conclusion: a range that changes how we see the sky. The GJX is not defined by speed or spectacle. It is defined by how far it can go, how long it can stay, and how much it can observe. Strategic range is not just distance on a map. It is the result of careful design, efficient engines, advanced sensors, and resilient communication systems, all working together. And in that sense, the GJX represents something larger than a single drone. It reflects how aerospace technology continues to push boundaries, quietly reshaping the way we understand the sky above us.